So, good evening, everyone. Hope you're all doing great. So, last time, just a quick recap, we basically had a session on word vectors and how the underlying transformers and attention architecture of LLMs works. And this really fun session we have today on prompt engineering is basically the application of that. So the intuition behind that is that basically, every single LLM simply takes vectors that represent the context that you put into it, and it multiplies with the weights of the LLM that OpenAI or whoever has trained. Uh, so it's really expensive to fine tune, and it's extremely expensive to like create a new model and train one. But if you want to change the behavior of a model, how do you do that? Well, the obvious part is you can change the context, and you can really cleverly manipulate the context so that you get the exact output you want. So that's the idea behind prompt engineering. So as you can see, Sam Altman says writing a great prompt is a high leverage skill, and hopefully I'll have convinced all of you of that with today's session, because you can see just how powerful it really is. So I'm pretty sure all of you would have at least heard of prompt engineering. It was like a big buzzword a year ago. So can any of you tell me, like, what do you think prompt engineering is, or what have you heard about it? Okay, no
Prompt
issues.
engineering basically
Yeah.
means to give the correct set of questions or to get a correct set of statements for getting the correct or preferred result. Like setting
Yep,
a concept, for
exactly.
example, being like in image generation, we set the environment, the tone, the format, that sort of stuff.
Yeah, exactly. So basically, what prompt engineering lets you do is it lets you change the context. So you can put in, different questions. You can set context for the LLM so that basically the answer you get is aligned to that context. So where does prompt engineering fit in? Basically, prompt engineering is the art of crafting these pieces of contexts and basically guiding the model towards the outcome you want by, setting up those contexts. So it's also called in context learning, and basically model learning happens when you change the weights of the model itself, but in context learning basically changes the vectors that represent your context without changing the model itself. So you can kind of imagine it's really powerful, because without fine tuning a model you can drastically change the kind of behavior of it. So uh, there's a really great 6-minute video here which will basically explain to you what one shot prompting, zero shot prompting, and multi shot prompting is. So let's watch it.
Have you ever stopped to think and wonder, where does the information come from that gets generated by the large language model? So in the last example, we prompted the large language model with once upon a time, and it generated there was a magic castle. Where did that magic castle come from? Well, the answer in that case was, well, it was my head, but the answer in that case, if it was actually a large language model that was doing that, is that it would have come from the pre-training of that model. So during the pre-training stage is when the model gets created and generated for the first time. And usually with a large language model, they'll take all of the data they can find on the internet, so the complete works of Shakespeare, all of Wikipedia, everything that they can find on Stack Overflow, and they will use it to train the model to get an understanding of natural language. And so in this case, that's where that information comes from. But what about if we want the large language model to work on our data, something that we have that the model's not seen during its pre-training? Well, that's where in-context learning comes in. And in-context learning is a type of prompt engineering. And if there's one thing that you should drill down on and get across in the whole area of generative AI, I think it's prompt engineering, because it really ties everything together. So let's take a look at in-context learning in a bit more detail. We're going to use the example of summarization, so text summarization. We have some text, say for example the minutes of a meeting, and we want the large language model to provide a summary of those minutes. We can absolutely do that. And so what we might do is we might generate or engineer a prompt that says, summarize this text, and then we can provide the minutes of the meeting inside the prompt as part of the prompt. So we're engineering our prompt. And we can pass all of that to the large language model and see what it'll do. Now, with large language models, where we're talking about hundreds of billions of parameters, they're actually pretty good at this. And this is called zero-shot prompting, because we're not giving it anything other than just the information it needs, and we ask it to please provide the completion, which in this case, hopefully, is the summarization of the minutes of our meeting. But there's a little problem with that. We weren't able to explain in any more detail to the large language model how we wanted the summary to be presented. Did we want a very, very concise summary or a slightly longer one? Did we want the language to be very formal or kind of informal? Did we want to zero in on who was present in the meeting? All of these different things that we haven't explained to the large language model. And so we can provide more information to the large language model in the command or the prompt to do the summarization. And we can do that by providing an example. Imagine for a moment that you have a new intern at your organization and they have arrived and you say to them, please summarize the minutes of this meeting. And they might be very, very keen and very capable, and they take all of those minutes, they diligently go away and write up a summary and provide it to you. And you say, well, actually, that's not quite what I was after. Now, what would a reasonable response for that intern be at that point, apart from go and summarize your own minutes? They might say to you, well, can you give me an example? And that's exactly what we can do with a large language model, with something that we call one-shot inference. And one-shot inference, rather than just giving it the text that we want to summarize, we can actually give it an example of some text and an example summary inside of the prompt. And then we can append the please summarize this text again and provide the actual text that we want the model to summarize. So by providing an example to the large language model, it has the ability to be able to see the kind of summary that we want and understand a little bit more about the task that we're asking it to do. And so that is one-shot inference. Now, it could be that maybe the model is kind of a bit smaller and a little bit less capable, or maybe the specifics of what we want the model to do are kind of complex. Maybe we need to give it more than one example, and so we can do that with few-shot inference. And as you can see, we can start to build up a prompt which is really quite long with many examples of what we want. Now, this is an example where we're doing summarization of text. Imagine that we were doing sentiment analysis, or we were looking at product reviews, and we want to know if they were positive or negative or neutral. In that case, where we've got a multi-class classification problem, it's probably a good idea to have few-shot inference, where we give the model examples of what we think is positive, about what we think is negative, about what we think is neutral. And this, in-context learning, can get you a long way with a capable large language model and some creative use of prompt engineering like this. You can get the large language model to produce what you want. But there is one drawback. As you can see, the more information that you add into the prompt, the larger the prompt. And if you remember the context window that we looked at in the previous lesson, well, the context window is of a fixed size. There is a limit to the amount of information we can put into the model. And you'll also remember that the context window contains the completion as we're generating the next tokens as well. So if your large language model is still not performing after you've provided many examples, and you're getting to the point where you just can't fit any more examples in, well, at that point, you have to start thinking about fine-tuning your large language model. And that's what we're going to take a look at in the next video.
Yep. All right. So I hope everybody saw the video and understood essentially what it's talking about. If not, then I'm going to just summarize it briefly. So what he was demonstrating is something which is a very traditional kind of prompt engineering called zero-shot, one-shot, and two-shot prompting. zero shot is basically the traditional kind of prompting that you do when, for example, you want to chat GPT or NLN assignment, right? You give it some poetry and then you say, summarize this for me, and it'll do it for you. But usually the results are not very good. So that's where multi-shot prompting comes in. What multi-shot prompting does is you give it two or three, poems before, and you give it two or three example summaries. And this kind of in-context learning lets, chat GPT or whatever model you have to kind of learn how you want the output to be and adapt its output. So it it's a really good way to alter the kind of output of a model without having to do very much effort. So here are a few guidelines for good prompts. Be concise, because the words are getting vectorized. So having a long and very drawn out kind of conversational question might not be good for models, and usually briefer models will give you a briefer prompts will give you a cleaner result with most models. You also need to be extremely specific. This is powerful because it will give me a very uh, structured answer, and that basically lets you kind of control the output a bit more. uh, when it comes to the prompt, you should really only ask one task at a time, which is it'll get confused if you're trying to make it answer two tasks at once, especially if they're very complex tasks. So they've given a few examples here. Zero shot prompting is you just ask it, is a goldfish a pet or not a pet? And usually a large model like ChatGPT for such a simple question will absolutely give you a really good answer. Uh, but imagine this was like a summarization task, or you were working with Llama 27B, for example, which is a much lower parameter model. Uh, in those situations, what will help you is you can tell it, for instance, a dog is a pet. Now, using this context, tell me, is a goldfish a pet or not? And few shot prompting is, a dog is a pet, a lion is not a pet. Now tell me, is a goldfish a pet or not? So this is a very basic example in order for you to understand what a multi-shot prompt is. So now I'm going to basically show you an example. So essentially, let's do some I got some interviews from I got some reviews from IMDb for movies, and we're going to do some sentiment analysis on them and kind of predict from 0 to 10 what the rating of these should be. So uh, this is an AI playground. You could query this on ChatGPT as well, but AI playground is a Vercel website which allows you to play around with different models, and it's really helpful. So I'm going to put in a zero shot prompt, which basically gives a sentence and says, analyze the sentiment from 0 to 10. Uh, so now let's answer it. I think this is not working actually. So let's use ChatGPT. So it says, first of all, I wanted the output to be just a number instead of a paragraph. So I couldn't use basically this. If I was, creating an app where an LLM predicts a rating, I couldn't use this paragraph. I would want a pure numerical result. And what's more, if I keep giving this, it's unreliable. It gives you different kind of answers for this. Uh, so, and the answer is not in the format that I want. So now let's do a one shot prompt. What this is it's giving me, I'm giving it a review from IMDb with the rating that the person gave that movie, and then I'm telling it in a similar way, follow this instruction. So if I give it, it's still not in the exact way that I want, but the sentiment score changes and becomes kind of more accurate, right? So basically, this is a way to improve the accuracy of a model like ChatGPT for this task without necessarily, influencing the model weights itself. And you can do two-shot prompting as well. So two-shot prompting, basically, I've given it two reviews, two sentiment scores, and I'm telling it to give it the sentiment. And now the output is a little bit more formatted. So it's saying sentiment colon 7, and it's doing that reliably. So I can actually use this in a computer in a programming context later. So you know that is how multi-shot prompting works. And you might be thinking, okay, for this sentiment analysis task, it doesn't change the output much. but for harder tasks it does. So there's this basic review paper that came out. So here what you can see is this blue line is GPT-3. If you give it a zero shot prompt for, I think they did English to French translation. If you give it a zero shot prompt, then the accuracy is around 10%. So they had a data set of very, very difficult questions. However, if you give it a one shot, this accuracy jumps to 45%. That's huge because like you didn't have to change the architecture. You didn't have to do anything revolutionary with the weights. And this is literally just prompt engineering. It's something you could mess around with the GPT API, and you can get like from 10% to 50% insane increase in accuracy. So that is why people essentially do few shot prompt engineering, right? Okay, so let's look at the basic elements of a prompt. So essentially the do's and don'ts for a prompt is you want to start with the simplest possible prompt. So as you can see, these prompts that I gave were very, very simple. It's literally here's some example reviews with the output format, and in a similar way, follow this instruction. And then I wrote the exact same thing for the review that I want to analyze. So this is a very basic prompt. Then what you should do is uh, apply this prompt, see the results you're getting, and then iterate on it. For example, if ChatGPT is giving me a paragraph, you can add an instruct to the prompt that says, just give me a number in your output and don't give me a paragraph, for example. So this is called iterative prompt development. You start with the simple prompt that gives you the answer you want, and then you iterate on it to increase the accuracy step by step. You do want to avoid redundancy because that assigns extra weight to things that are to the context that is written twice. So you want to avoid redundancy at all costs. You want to be specific. You have to be as specific as possible. Uh, sometimes you have to tell a language model that just give me a number. So you want to write clear and precise instructions over there. So that is a few do's and don'ts for prompts. That kind of ends the session on prompt engineering. However, there's one more thing that I'd like to show you, and then Shaurya will kind of take over the workshop for token limits. So here's a small Python script. All this does is it contacts the GPT API, and I can put in a prompt and it will give me an answer. It's very basic, and I'll be sharing this script with you as after the session. So you can also, if you have an OpenAI API key, then you can also kind of mess around with this. So basically, what temperature does is that you might recall in the last lecture that a transformers model is probabilistic, right? The kind of outputs gives you a range of probabilities of what token is going to come next. So yeah, does anyone have can anyone guess what temperature would do in the for LLMs? Or just like what kind of intuition you get from temperature? Okay, so essentially what temperature does is it influences the creativity of a model. What it does is that if you have a temperature that is extremely low, then it will basically almost always go with the most probable token. So the answers are more predictable, they're more technical, and sometimes they tend to be more accurate. When it comes to high temperatures, the answers tend to be a bit more creative. So depending on the kind of application that you're building out with your LLM, temperature can be a very important tool to play around with in addition to prompt engineering. So here I have basically just once upon a time, it's going to continue to write a story, right? And I've set the temperature to 0.1, which is extremely low. So let's run this. Yeah. So this is giving me basically a fairy tale kind of written story that starts with the context that I've given it. The thing is, if I run it again, then it actually uses the exact same name and almost the exact same story. It uses Aurora, probably because when they trained ChatGPT, most of the kind of fairy tale stories or stories beginning with once upon a time usually use the name Aurora. So that is kind of the most probable token, and that's why it's always saying Aurora. It's not being very creative over here. Now, if I set the temperature to 1.1, which is pretty high, and I run the same thing again, it's being a lot more creative now, and it uses a different name. If I run it again, it's probably going to use a different name again. Well, it used the same name, but yeah. So essentially, for a creative prompt where you have to write a story, you want the temperature to be relatively high. Now I can show you the opposite situation. So here's the same code, but now I'm telling it to write some Python code. Let's see what happens when I give it a temperature of 0.1. What's the name? Code inference. Okay. Yeah. So what it does is it writes code in Python. If I rerun it, it writes the same code, which makes sense because this code is correct. It works. So it should write the same thing again. Right. But if I give it like a really high temperature, something like 1.5, let's say, first it's going to be kind of more creative with its answers. So it'll give you it's giving you different methods to parse a CSV. But what I wanted to show you is what can happen with extreme temperatures. So ChatGPT only allows you to play with a temperature up to 2. So let's set it at 1.9 and see what happens. So this is sometimes what happens. When you set the temperature to be too high, the the API can become a bit too creative and it will just start spitting out nonsense, right? So temperature is another thing that I wanted to kind of show you guys because it's, I think, a very important part of creating prompts and playing around with LLMs and things like that. So yeah, that's about it. Here there's some bonus resources, which is kind of some documentation when it comes to prompt engineering, and I really recommend you guys to go through it. Yeah, and this is why prompt engineering is really important. So have you guys seen this anywhere online recently?
That's Ola's script.
Yeah, exactly. So this is Ola's Krutrim AI, which uses GPT 3.5 under the hood, which is fine. But basically, when you create a prompt like this, you want to set guardrails. Now, what does that prompt look like? A guardrail prompt looks something like you are a chatbot that helps out Ola's customers. Your name is Krutrim, and you should only answer questions that relate to uh, Ola's customer service. And you should reply, "I am not qualified to answer this" if they ask you any other question. So they what they should have done is kind of add a guardrail prompt. And guardrail prompts in 90% of cases prevents stuff like this, where a completely unrelated chatbot, you can ask it how to code with Java and it just gives you the answer, right? And this if you straight up ask it what its large language models is, instead of Krutrim, it says OpenAI. So a very basic kind of context where you say you're a Ola chatbot, which is named Krutrim, would have prevented this. So this is kind of how, in a production app, a prompt is extremely useful. Uh, yeah. So that's about it. And just a very kind of cool thing I wanted to show you, just to show you kind of the potential of this kind of technology. So this is Find. Find is a chatbot which basically their idea is they use smaller models. So their current model is just Llama 34B. It's much smaller than ChatGPT, which has like 140 billion parameters. But if you ask it any programming questions, so tell me how to implement Supabase in my application. If I get an answer like this, what it does is it basically finds documentation and finds stuff from Stack Overflow, and it also does some really genius prompting under the hood. And what you can see is that this kind of answer is a lot more systematic. It's a lot more helpful than something you would get from even GPT, despite being a much smaller model. So this is kind of an app that I wanted to show you, which is out there, which really demonstrates the potential of this, because they're literally using a 34B model, which is 5 times cheaper than GPT and still is getting close results. So that is kind of a testament to how amazing retrieval plus prompt engineering can be when it comes to applications that use LLMs. So yeah, that's about all I wanted to show for the prompt engineering part of it. So Shaurya, I think, will continue with our navigating token limit section. So I'll stop sharing now.
Yeah, hi. Thank you so much, Dhruv. Very insightful, of course, and a lot of examples that were very important, I think. So I think we use find quite a lot, in production code as well. So definitely a great app. Also YC backed. So yeah, hi guys. I will be taking you through the navigating token limit section. I mean, this is a fairly easy, fairly simple to understand part of this course. So very simply put, the way these models are made based on multiple parameters, they each have certain token limits. So first of all, what is a token? I think on an average, you could say about two tokens correspond to one word approximately. But that really depends on the kind of tokenization people are doing. So for example, OpenAI would do a different type of tokenization than Llama would, than Mixtral would, as an example. And each of them have their own tokenizers, right? That run on words and figure out number of tokens. So for example, an OpenAI tokenizer may do 20 tokens for 10 words, or an Llama tokenizer may do 22 tokens for 10 words. So it totally depends on the kind of tokenizer and the kind of model you're using, but it's roughly about two tokens a word is what you can do back, napkin calculation if you want to. Now, over here, so there are two words. There's one token limits. These dictate the number of tokens an LLM can handle in one go, which means that how long your prompt to the LLM can be is dictated by this. And the second thing is estimated word counts, which is the approximate number of words that can fit within a model's token limit. So obviously, depending on the tokenizer, you will get it. The estimated word count that you can input for a given prompt is totally a function of the token limit of the model. So, for example, when you try copy pasting a long Wikipedia article into ChatGPT, you may notice this error. Now, this error is due to the fact that GPT 3.5 has a fixed token limit capacity beyond which it will not be able to answer any question from the prompt that has been given. So, this is a quick table that talks about the token limits from different models and the estimated word counts based on the vectorization. So over here, you can clearly see that GPT-4 has a token limit of about 32,000 32,000 tokens, which corresponds to about 25,000 words. So that's roughly, you could say 1.6, 1.7 tokens per word, right? And similarly, GPT 3.5 has a 4,000 token limit that corresponds to about 3,083 words, and correspondingly for Llama. And then Claude, which was the model by Anthropic that came out recently, not Claude 2, Claude 3 at least, but Claude 2 as well, boasts a token limit of over 100,000 tokens, which implies that you can put in a much longer prompt and it will still give you a much better answer. So this also, it really factors into the prompt engineering part of it quite a lot, because as you know that to add any guardrail prompt or to add any sort of multi-shot, learning in the prompts, you will have to have a longer prompt to be put in so that it happens all in one, at one time. So for example, when you're putting in, for example, a guardrail prompt saying, as Dhruv discussed, I am an Ola's you are an Ola AI bot and your name is Krutrim. That takes a certain number of tokens, a certain number of words. And if I have a longer limit, I will be able to do this much more efficiently. Over here, I mean, this is also a very interesting thing that you guys should note, which is the use cases for each of these models that they are known for. I mean, I would say read through this is nothing to do with the token limit. It is a little bit to do with the token limit, but not much. But basically, GPT-4 is good for complex reasoning. GPT 3.5 for relatively simpler reasoning. Llama 2 is open source. I already discussed what open source versus closed source models were in the first session. And then Claude 2 is a closed source model that has a stronger reasoning ability than GPT 3.5 and a much higher token limit. So it allows for safer AI applications. The reason it's safer AI is because it implements something called constitutional AI, and we'll go through that, at some other point during the course. Yeah, so LLMs process prompts based on vast data sets, leading to token limits that cap the amount of text they can handle in one interaction. Understanding these limits are essential for crafting effective prompts, as I said. So obviously, a nuanced understanding of the token limits is key to maximizing the your LLM interaction and your interaction with the LLM in the first place. Also, you can have tailored document management strategies that can help navigate the constraints imposed by token limits. What this means is that, for example, if you have a large PDF through which you want to actually search something or query something, you can actually do some design thinking in order to actually only extract the relevant portions of that document, so that only a small amount of tokens is actually used in terms of the ground truth data that you're supplying to the model when you're querying the model. And employing these techniques enhances the effectiveness and accuracy of information processing. So yeah, so now we'll go through the section which is navigating token limit constraints with prompt engineering. So when it comes to simple queries, such as to understand token limits, there are very simple things you can do. The first thing you do is ask an LLM how many tokens can you support. So, for example, if I go to ChatGPT, I think classic demo over here. Just a second while I log in. While I just quickly go to ChatGPT and use, ChatGPT for, uh, okay. So, how many tokens do you support? So in terms of raw text input, I can process up to 2048 tokens at once. So as you can see, that this has already told you the exact token limit of GPT that is running over here. Now, of course, a token limit is very obviously a competitive edge, because as I already discussed, that a model that has a significantly higher token limit allows you to do much better prompting. So that means that, if you use Claude 2 or Claude 3, then you will be able to do much better prompting, get much more accurate answers. This is not to do with the pricing though, because the pricing, the way these APIs are priced are not per query, rather they are priced per millions of tokens inputted or outputted. So while your price would be, the same, or depending on the exact model's specific pricing, you will definitely be able to get much more accurate answers by creating much longer prompts that are based on many more tokens. So yeah, and then there are a couple of strategies that exist to manage excess length. So if you're dealing with documents that are very large, as I already talked before, you have three ways to do it. You can either truncate or divide. You can break down the document into sequential sections, ensuring each is within the token limit. While this is a good strategy, it's not exactly perfect, because obviously you lose context, which is
Hello?
like, yeah,
Yeah, sorry to interrupt. Can you just speed like a little slow speed? I mean, I really cannot
yeah, yeah,
understand what you're talking.
yeah, yeah.
Yeah, speed
So
is not
sorry.
great.
Sure. Yeah. So when you're dealing with a document that exceeds these token limits, there are a couple of strategies that exist in order to help you minimize the risk of losing essential information. So let's assume that there is a document and it has 4,000 tokens worth of information. Obviously, you won't be able to put it into GPT all in once. So what you do is that you can either truncate or divide the document, which means that maybe if the document has multiple sections, like if you're talking about a research paper, if the research paper has an abstract followed by section 1, followed by section 2. You can truncate it into abstract and then ask a prompt on the abstract. Then section 1, ask a prompt on section 1. So if you're, let's say, you want to summarize a research paper, you can break it down by section and then summarize each section separately by prompting, and ensuring the entire prompt is within the token limit. But while this is obviously a decent strategy, it is not the best, because of the fact that in you will basically lose context token by token unless the model has very good recall potential, or very good ability to be able to do conversational, very good conversational ability, where the last prompt affects the next prompt. So ideally, you want to put everything in one prompt itself. So a better way to do it is eliminate irrelevancies. So if you have a large chunk of data, let's say 4,000 tokens in this document, if you realize that 1,500 tokens of these 4,000 tokens, or 2,500 tokens of these 4,000 tokens are actually not so relevant in some way, and you remove this before putting it back into the model, then you can actually have this 500 extra tokens, that you have to put in the prompt, and the 1,500 relevant tokens of the information that you're trying to parse to get the best answer possible. And the last being retrieval augmented generation, which is this huge buzzword nowadays, which we call RAG. So RAG, or retrieval augmented generation, utilizes techniques that allow the LLM to access external information. So effectively extending the document size it can handle. So basically, we'll be talking about RAG very extensively in the near future. But the point of RAG is essentially to allow the document to find from an external source. So like if you have a database of information and you ask a query, what you basically do is you try to find out what is the most relevant chunk in that database to that query. Chunk as in relevant set of tokens in the database to the query that you're asking. Bring those tokens out and then put it back as part of the prompt. And what this helps do is mitigate hallucinations, which is what we will talk about very soon. And not only that, it also allows us to do much better prompting and also reduce the irrelevant tokens that are going into our prompt, allowing for allowing us to manage excess length when putting in prompts. So there are a couple of extra links on token limits that you guys can go through. One is from Microsoft, the other one is from OpenAI. Both detail very clearly efficient prompt design and tokens, and you can go through that on your own time. So, how many of you guys have heard of hallucinations before? Does anyone know what a hallucination in a model is?
Basically, it generates information that is not needed, or like random information, some sort of
Okay.
stuff.
So, can you give me an example of a hallucination?
Yeah, for example, like we asked about like a particular story or example. For example, we have been on assignment on that, but for instead of just knowing about it, it is generating like random literature things or random like this pieces, excerpt which are like not related to subjects.
Sure.
Some sort of
Yeah, exactly. So, interesting fact, in 2023, Cambridge Dictionary Word of the Year was hallucinate because of how extensively, how much of an extensive problem hallucinations in LLMs were. So, basically, while LLMs can produce text that is impressively coherent, they can also produce content that includes details that are entirely hallucinated or invented, particularly when the topic is outside the training data or the prompt lacks specificity. So let me take you through a couple of types of hallucinations. The first being sentence contradictions. So for example, if an LLM is outputting some huge paragraph, and in one place in the paragraph, the LLM has said the Eiffel Tower is located in Paris, and later claims the Eiffel Tower can be found in Berlin. This is an ideal example of a sentence contradiction. So a prompt contradiction is basically any factual information that has been provided in the prompt. The model actually takes that information and it uses it in the wrong way and actually tries to contradict whatever information is in the prompt. So for example, if I put a guardrail prompt saying that you are Ola's AI and your name is Krutram, and then somebody asks a query saying what's your name, and the model actually answers something like or even better, if I tell ChatGPT that your name is you're an Ola chatbot and your name is Krutram, and then what is your name in the same prompt, and ChatGPT responds with no, my name is ChatGPT and I'm from OpenAI, then it is a prompt contradiction. This is also a type of hallucination. Factual hallucinations are basically in the case that they answer facts about human history or different things in a wrong way, and this is probably because of the fact that the training data in some ways is corrupted, where the training data for some odd reason decides that it will actually, put in 1969 as the most probable year where Neil Armstrong landed on Mars. And this could either be because training data is corrupted or because the temperature is very high. The point of, as Dhruv discussed, the point of a temperature being very high is that it may not go for the most probable next token. It may go to some other token that is not as probable to kind of switch up the answer that is coming out. And in this case, factuality is kind of compromised when it comes in increasing temperature for obvious reasons. And finally, nonsensical or irrelevant information. It may generate content that is either irrelevant or makes no sense within given context. In response to a prompt asking about the history of the internet, the LLM starts discussing the dietary habits of penguins. This is a completely nonsensical information that is also part of the hallucinations. So as I already discussed above, there are multiple reasons that cause hallucinations. The first and foremost being data quality. If the data that the LLM is being trained on is not of the best quality, then automatically the most probabilistic next token that will be generated may be factually incorrect, for example. The second is the generation method. So, as I already discussed, if you put the temperature very, very high, then it all obviously is trying to be more creative as compared to factual. And the way it's doing that is by probabilistically not selecting the most probabilistically next token, but it's selecting something that is lesser probable just to switch up the kind of answer and create a more creative and interesting answer in general. This is what we call the generation method. If your generation method is not the best, or it relies more on creativity than factual information, then it may actually end up hallucinating. And the fact is input context. So, the entire prompt contradiction that we talked about, that can obviously happen in the case that the prompt that you're giving is not the best prompt. So if it's vague or non-specific or doesn't follow the best prompt guidelines that we've already talked about in this section, then it may end up in giving inaccurate outputs, especially in prompt contradiction. So there are multiple ways to mitigate hallucinations, and this is a large open research topic in today's day and age that is very, very popular. So So a very, again, as we already discussed, retrieval augmented generation, it not only ensures that only relevant information is put in the prompt, it also ensures that hallucinations in general are mitigated. So there are a lot of, people that are, a lot of players who are actually trying to figure out, how to do this. So Pinecone very recently, a very large vector database, they came up in their research lab with a very interesting zero-shot learning technique to mitigate hallucinations. Retrieval augmented generation, while sometimes failing, is usually very, very reliable when it comes to mitigating hallucinations. So, responsible AI and awareness, being aware. So, acknowledge the propensity of LLMs to produce hallucinations. So, obviously, if you know that the LLM can produce hallucinations, you will be much more likely to create guardrails in such a way that it mitigates for the case that it does produce the hallucinations. Second is rigorous testing. When you do create some sort of model, ensure to do a lot of user testing, a lot of internal testing to ensure that whatever hypothesis that you have in terms of how well or badly it's going to perform, it actually performs at par with our hypothesis. And finally, human oversight. So if you implement a robust mechanism for human review and intervention, it ensures that any inaccuracies are usually mitigated. So that also comes in as part of rigorous testing. And building the foundations for RAG. And this is what our focus in the near future is going to be, which is retrieval augmented generation. So RAG combines the generative capability of LLMs with real-time verifiable data retrieval, so significantly reducing the occurrence of effects of hallucinations by anchoring the model's output. So what this really means is that what you're going to do is that you're going to take in a query, you're going to vectorize that query, and against a database of ground truth data that you believe is 100% true, you're going to find the most relevant chunk, that the most relevant bit of information that vectorially is very mathematically similar to the query that you put in, and then you're going to retrieve that chunk and put it as part of the query. So for example, if I ask something like, um, um, when did who landed on the moon first? And if I have this huge database where, I have some line in the database written Neil Armstrong landed on the moon first, what RAG will basically do is take my prompt, vectorize it, compare it against the database, find this chunk that says Neil Armstrong landed on the moon first, take that, put it back into the query. So your entire new query will become who landed on the moon first? Neil Armstrong landed on the moon first. Not only that, you can also add guardrails. Like you can say, use this information as the ground truth factual data that you will use to generate an answer, and then put in the information, append the information of the Neil Armstrong land on the moon first. And what the model will basically do is ensure that whatever answer is coming exactly from that specific chunk that you have actually retrieved. So we'll be talking a lot about this in the next section. Yeah, and we have a quick exercise that I think Dhruv will, take you guys through very quickly. So that's been my time. And thank you guys for listening. I'll just hand it over to Dhruv so he can take you guys through the exercise.
Yeah, sure. I'll share my screen in just a moment. Yeah. Okay. So essentially, there's a little bit of a interesting exercise that you have in order for you to actually sit and get an experience of what prompt engineering is actually like. So here you have basically a really long story that's, I think, written using ChatGPT itself or some AI model. So yeah, this is a really long story that you can go through, and here's your task. So essentially what you have to do is design a prompt which takes that story and extends the story, right? And the story should be coherent. It should maybe reuse characters that have appeared before. It should be interesting, etc., etc. Subtask 2 that you have is few shot prompting for character analysis. So essentially what you want to do is put two or three prompts that say this is the context in which this character is mentioned, and in this context this character's emotional state is this, right? You want four or five of those, and then you finally put in the prompt to analyze a character in a given situation, and you want to gauge what that character analysis is like. So is this person sad in this sentence, is this person happy, etc., etc. Subtask 3 is limitation recognition. So basically ChatGPT, and in the context of this, you want to ask, what do you think is the US? It will force the LLM innovations in LLMs and apply based on 2021 data, 2023 data. It doesn't know GPT-4 exists, so you'll really firsthand get to know what the limitation of trying to use GPT to obtain information is. And of course, there's a Google form where you can submit the responses. In case you don't want to do that, there's also an alternate kind of story, not a story, an alternate assignment that you have. Essentially, they've given a blog post which is Python and finance, right? So basically, what you want to do is the concepts in this blog that you do not understand. The concept that, like, Docker is a library, Docker software that allows you to containerize your applications and deploy them really easily. And Streamlit is a Python library that allows you to very quickly build a UI for a data science application. So we want you to use LLMs to figure out what Docker is, what Streamlit is, and if, for example, if the answer is too technical, you can prompt it to give you a less technical answer, or vice versa. So this will also give you kind of a taste of prompting of LLMs. So yeah, this is essentially the task. There's a Google form for you to submit. So yeah, that concludes this session. I'll also be sharing some cool resources on the group for you guys to play around with prompt engineering, because it can be very, very fun. So that's about it. I hope you enjoyed this session and learned a lot. I'll see you all later.